Okay. Welcome back to stream 2 here at DSC MENA. Uh, Up next is Manoj, Vice President at DBS Bank, and he will guide us through a practical introduction to AI in finance, from building a simple linear regression model to estimate expenses, all the way is detecting fraud using supervised learning. And I'll let you start now. Thank you.
Thank you. Welcome all, and good afternoon in Egypt today, and good evening in Singapore. Yeah. So, welcome to my presentation on AI in finance. Uh, so, I will discuss how AI and ML are revolutionizing the financial industry and enhancing efficiency, security, and customer experiences. Uh, so this session is more about how the real world has inspired AI ML and how we are teaching machines the way human has learned over the years. So my view on AI ML is that we must understand from the real world examples, and then we must move on step by step. So we will just have from insights, and then later on we will have some actions. So we will have Python coding, and we'll go through at least two use cases today on the session. So I'll move forward. This is about me. I'm Vice President of Architecture and Development at DBS Bank. So I'm leading innovative projects to enhance financial systems scalability and efficiency. So I have worked on back-end technologies. Later on, I moved to some front-end work as well. And I have delivered projects like automated loan approval, DigiVault, fraud detection, and collateral management, and saving millions for the banks I have worked for. So I'm an IIT Roorkee graduate, and I have passed CFA level 3. And sometime back, I just completed my postgraduate program in AI and ML from Universities of the Texas. So I'm more focused on the digital transformation of the financial industry. So a digital transformation of my bank. Yeah. So we'll move forward. This is the agenda for today. And what we'll be doing is we will be just decoding these AI/ML terms. That what are these terms? So as I said that I want to relate to the real time examples. So that's what we will do today. Then I'll just take you to the old days where decisions were made by data driven only. So they have always been data driven. And then how data science improved the accuracy of those decisions. Then evolution of data science, some examples in finance, and then why institutions are adopting AI and ML. And then we will just go through some applications of AI and ML. And in the end, we will build one first machine learning model, very simple model. And then from there, we will move to a monthly expense model, and then your unsupervised learning to basically detect fraud. So this is the agenda for today. I'll be starting on so AI and ML terms. I mean, so these are like see main four terms you might have been hearing. So what is artificial intelligence? So artificial intelligence is nothing but teaching computers to think and act like humans. So it allows machines to learn from experiences, make decisions, and even solve problems, just like we do, but often much faster and with way more data. So we see AI everywhere today, from chatbots to self-driving cars, even recommendations on Netflix. It's changing how we interact with technology in ways we never imagined. So now then coming to the machine learning. So machine learning is again, it is basically learning from the patterns and then making some predictions. Machine learning is of two types. So you have a supervised machine learning and you have unsupervised machine learning. Supervised machine learning is already having uh, the result what you are expecting, right? So the examples are your linear regression, and then unsupervised learning is more of a finding the patterns, identifying the features, right? And We will be covering both today. Then there's another part within machine learning, and which is your deep learning. So deep learning is again inspired from neural networks in human brain. However, in last a few decades, this inspiration basically has moved from the actual neural network, and we have moved ahead a lot. And then the last one is your generative AI, I think, which everyone using today, Gemini or ChatGPT, that you are asking to generate something. So you are asking AI to generate something for me. So whether the image or some content, and that is your Gen AI. So we'll move forward. Yeah. So this is very interesting point. The decisions were always data driven. So what today machines are doing, or what today AI ML is doing, is nothing new actually. So if you really look at, I mean, how humans have evolved, they have evolved also from the same formula, that they observed something, and from those observations they identified patterns, that these are the patterns, and based on those patterns they made decisions. So if you really look at it, that our ancestors, they already knew the movement of sun and moon, and based on those sun and moon they could quite accurately determine the length of days and nights. And using those lengths of days and nights, they could adjust their daily routine. So like winters, sun will rise late, in summers sun will rise early, and then accordingly they can wake up early, sleep early, like that. Now seasonal changes. So seasonal changes also, they are not new for us. We already knew that during monsoon it will rain, during colder during winters it will be cold, right? So these are basically nothing but observations. From there we identify patterns, like which part of the year this will happen, and then accordingly we will change our lifestyle. We can also plan for crop cultivations. Then your geographical transformations. We already know that on plains it will be hot, in hills it will be cold, and then we can decide, okay, when to travel, where to travel. Similarly, types of food available. We have multiple foods, kind of food available, and then we see the pattern. Okay, by eating this kind of food, we feel healthy. By eating this kind of food, we don't feel healthy. And then we can accordingly we can make the decisions. Okay, whether to eat dry fruits or not. So you're actually your machine learning is doing the same thing today. What it does, it basically takes the raw data, it collects the raw data, which is nothing but your observations, right, from your past, from your historical data. From that data, what it does, it basically extract features, or you can say it basically sees the patterns, and then from those patterns it learns. Okay, fine, I think this works this way, this works this way, and then accordingly, if in future, if I provide any future data, I will use that learning from past, and then predict a event, or predict an action, that what should I do. So essentially nothing has changed. So it's observations, your patterns, and then the decisions what you are making. The only thing what has changed is that the capacity to store that historical data. Before, 1%, 2%, or even the non-person couldn't store that much data. But right now we have huge data with us, and then we can learn a lot from it at very fraction of seconds speed, and then we can make decisions, we can predict decisions. So this is, again, I think I'm just going through data science. That data science is, I mean, what is data science? It is so three main fields, I would say. Maths, your then your computer science, and then your domain skills, right? So you basically mathematics, computer science, domain skills. Domain skills and maths, when it meets, then you basically make statistical models, okay? And then if you computer science and your domain skills, if it means, then you have your engineering, data engineering. And if your maths and computer science meets, then you have machine learning algos. And if all three things meet, then you have data science. And this is your evolution of data science. So I think we are moved forward in last few decades, or basically starting 1940s, 1950s. We have made tremendous progress in science and technology, and also parallelly we made good progress in statistical methods. So Initial days, I mean, I explained to you already, the 1940s, around 1940s, we still had mental methods, during that time we developed probability theory. Also we invented audio tapes, telegraph, right? Then it was the age of computers, so we are, decision. Then in the uh, statistical, or your data science, you got decision theory, robust statistics. And then in the computer science, we had operating systems, programming languages, right? Then year 1990s. Then we got like artificial intelligence. We could develop some more theories which basically improved our decisions, cloud computing, big data in computer science. Then again, now when we look at the future, or in the current era, or like the next few decades, so you have edge computing, quantum computing, a lot more. So, and then combinations of these technologies like blockchain plus artificial intelligence, so those things we will be using. Yeah. So now I think coming to the finance section of it. So how evolution of AI and ML has been in finance, right? So I think this will be more on the finance side of it. So in the old days, I think, and not that old, because even when I started working, I used those models, right, which were not inspired by artificial intelligence or machine learning, right? So I mean, long back when we were working on a fraud detection application, what we had is like, very simple rules. So like if you change your mobile device, okay, or if you change your mobile number, right, or if you change your some slight pattern, so hardly we had 3 4 static rules, and based on which we would think, okay, fine, this could be a fraud event. Similarly, in your credit scoring, so it was very manual, tedious process, and even just 5 6 years back, it would take almost 1 month or 2 months to get your loan approved. I mean, can you imagine that? That you applied, I mean, you want to make some transaction, you want to buy some property, or you had some family need, you applied for a loan, and then that loan will be approved like probably in months. So it, because it was very tedious manual process, we did not know that how to calculate. I mean, so we had some methods which were damn static. And then the another problem with those methods was that, after not even 3 4 years, after 2 years only, those models will expire, because the time has changed, technology has changed, people, the interest of people have changed, the financial needs of people have changed. So now you have to basically modify your model, you have to improve your model, probably sometimes you have to completely redo your model. And then what will happen, you will come up with the new model, then you will ask your software team to implement that model, and then software team will take at least a year to implement it. And by the time the model is implemented, you are actually already, outdated. So that's how, the things were difficult for basically credit scoring to approve the loans, and to identify the right person to give loan to, or to not to give a loan to a wrong person, right? So it was like quite basic statistical models that those were used for even risk assessment. Then your machine learning came in, and then fraud detection based on pattern recognition. So then your machine learning can do pattern recognition, and then it can advise you that, these are, so that's a, more broader space. You got into more broader uh, patterns to identify. Similarly, algo trading. So algo trading has also gone through a lot of changes. And then now you have chatbots and robo advisors, so you have personal touch, right? So when you go to a site, right, and a website, well, some chatbot will pop you up, how can I help you today, right? Or even like when you reach out to banks, right, before you had to call them, and lines were busy, but now you can reach out, and sometimes you prefer, actually, I mean, uh, mm, like when I interact with Kotak Mahindra Bank in India, right, I prefer talking to a chatbot, because I can get my answers from there. So unless it is really a critical issue, or when something I have to change things which are required, or my documents and other things. Otherwise, all your matters can be resolved by chatbots. So those tasks which are repetitive, and also, you get a personal touch, because chatbots know, they know you, they know your profile, and then they know you, that how to talk to you, how to respond to you. So now I think then we came to the AI boom. So we are like sentiment analysis, your deep learning for financial forecasting, then AI powered automated loans. So now this has also changed. And then integration of blockchain and AI, as we said, for fraud prevention. Futures, as we discussed, I mean, finance also not uh, outside the technical world. It is like pretty much impacted, and I would say finance or banking, financial firms, they are impacted very highly. I mean, with the way technology is changing, banks, they are becoming technology firms. They are no more banks. So the financial industry, right, your financial firms, they are no more financial firms. They are actually technology firms now. So that's a major change in the shift. So I would say there's a major change in the domain that they were functioning in. Yeah. So I think let's move to the next slide. This is like why financial institutions are adopting AI and ML. I think probably pretty much we have almost a lot of things we have covered. That it is adding efficiency and cost reduction, so that we know that the repeated tasks are handled by chatbots. I'll give you one more example that so what happens, right, in the almost many firms have already transformed their the customer care service. So your customer care service in finances as well, that I have problem. I'm suppose my funds are not moving. I'm getting error in fund transfer, or I'm getting an error in remittances. My family has to receive remittances just now because they cannot wait. They need they are in some financial need. So I'll call customer care, and then these firms, what they have done, they have already when you make a call, some chatbot will pick up the call. They will basically read your transcripts, and then based on transcript they raise a ticket. So that they will raise a production ticket. That production ticket will go for again there also they have added uh, I mean so they have added intelligence to understand, okay, fine, this issue is related to, probably related to this issue, and they will basically add additional information before it really goes to a person who addresses it. So such efficiency has been added, and of course cost reduction in terms of human or resources, or also the time taken in the calls, and getting more customers for your bank. Similarly, it's like enhancing decision making, and as I said that data is new oil, right? And banks, specifically like investment banks and the larger big banks, right, they have huge data. They have historical data, and so for last few years they didn't know what to do with it. I mean, they were using for some trading algos and all, but now they have huge data, and then based on that data they can determine what to sell, who to call, okay, what decisions to make. So they have huge advantage with this AIML. And of course, with all this, customer services have also improved a lot. So I think moving fast, we have already covered applications of AI and credit scoring, approvals, customer churn prediction, whether customer is leaving your bank, right? Customer is leaving, throwing your credit cards, or whether if you want to run a personal loan campaigning, like whether you want to sell loans, right? You can use AI. You can do analysis on your customer data and then identify possible or basically customer to which you can sell the loans, then algo trading, fraud detection, and customer chatbots. This is all the multiple applications you have in AIML. So this is, I think, probably the favorite topic for today, that will be covering fraud detection. So I will not be covering the NLP part of fraud or behavior analysis. Rather, I'll be focusing today more on clustering. Okay, that so the offline mode of feature extraction. I think we'll go through some Python coding today. Yeah. So moving forward, yeah. So I think we have come up to uh, now this basic thing. So monthly expenses, right? You, when you are in home, and you are just sitting like end of March, and then you want to calculate the probably probable expense for the next month. And even if like you so I ask this to my 9 years old kid. Okay, that okay. So you are given expenses for January, February, March. So for 3 months, you are giving expenses. That these three expenses are 3,000, 3,200, and 2,800. So can you calculate April expenses for me? So I know that the audience, you might have already calculated the April expense by now. So my daughter also, this is simply what she did. Okay, I can tell you. So she just simply added all three and then divided by three. Simple average. So moving average, she got 3,000. Right. So this is what it is. So essentially, this is your machine learning model only. So this is the probably simplest and the easiest machine learning model what you can develop. That you have observations from past 3,000, 3,200, 2,800, right? You created a formula, okay, which is nothing but your model. What is model? Model is simple, the average. So average of your previous months, that is your model, right? And what is the prediction? So whatever average comes in, that is your prediction for April. So again, the same theme, very simple formula. So we'll move forward. Yeah. So now we'll break down these family expenses to few I mean the your independent variables, right, on which your monthly expense actually depend. So you will have a high level. If I really say, you have house rent, right? You will have grocery to buy. You have, like, your electricity bills, right? You will have, probably if you are owning car, then probably you will have petrol bills, right? And dining out, or party expenses, right? So uh, just for, again, for the use of sake of simplicity, I would just consider that, like house rent, grocery bills, and petrol, like suppose a stable. But because there are people who, in are, I mean, a lot of people are, they are like party lovers, right? And their maximum expenses are in parties. So when they go out dining out, parties, so their monthly expense, and especially when college grads, right, and when they get their first job, uh, their, I mean, most of their expenses are fixed. Okay, they don't change. So the only thing what they change is that how many times they went out for movie, how many times they went out for parties, and how many times they went out for dining out. So this is the only, so we can say we can build uh, one model, basically single variable linear regression model. Okay, where we assume that all the remaining expenses of for the month remain stable, and the only expense which is changing is party. Okay, so you will predict uh, your your monthly expense based on how many parties you are going to have in that month, right? So just single simple model. So this is, I think, I just put out expenses here, just I think random expenses. So if you really look at it, uh, so this is your monthly expenses on your y-axis. Probably I just forgot to put the value of y-axis. So on y-axis you have monthly expenses, and on your x-axis you have, suppose, your number of parties you are going to have, right? So if you have zero party, like suppose you didn't go out for dining, or you didn't go out for eating, eating food, right? So it comes zero. So you have basically your static expenses, which is $2,800, right, for your remaining expenses. And then as you move, like suppose if you go for one party, two party, and based on that your monthly expenses are changing. So if you really look at it, yeah, so that's what I just explained to you. So your stable uh, your stable expenses are 2,800. Your variable is party. And then this formula you must have read. I mean, it's okay. So I think I assuming this session is for uh, all people, like from, even from technology, and then people, folks who are like, building data science. So for data science people, this must be a very, cakewalk, very easy thing. For technology people, I have just to remind them that, this is the same equation what they studied in their 8th grade and 9th grade. Y equals to mx plus c. Okay, so this is no more different than that, right? So your constant, which is your y-intercept, right, is like nothing but your $2,800, and then your b1 is basically your slope of the line. So basically slope of this line which we can see here. Okay, so which is nothing but like suppose 100. Now based on so if number of parties you will have, like suppose in this month I had 4 parties, I will add 400. So 400 plus 2800 is nothing but your 3200, right? So that's how you can see from the graph as well. So if your number of parties 4, then you will have 3200. So this is your expense. So this is again your basically second simplest model uh, on your basically just expense on your party. But the world is not that straightforward. And when I grow, like suppose when I get married, right, then I have added one more person in my family. When I have kids, then I have some added more people in my family. And then probably my party will also go down, right? My movies going out for movies will also go down. And then my probably dining out also probably will go down when we have small kids, right? uh, and then but these things will go down, so we shouldn't be happy. We shouldn't be feeling happy about it, that my expense will go down. But in fact your expenses will go up, because you will have then childcare, you will have then education, then you will need to buy a bigger house, you have to pay more rent, right? You have to buy more grocery, you will be having more bills because your kids would require AC, right, aircon in your house. So things will change, right? So we'll move forward from this simple model to uh, a bigger model, right? So where basically we will be having multiple linear regression. So I'll be sharing my, okay, yeah. So this is what we have: monthly expenses, right? So I've already I created this data just for education purpose. Okay, so just to make you understand, and probably we'll go through one by one on this data. So problem statement, we already know now that our problem statement is very simple, straightforward, that I'm a data scientist, okay, and I'm given expense of families from recent past, and my job is to basically build a linear regression model to forecast monthly expenses, right? And then basically some do analysis on that, the possible okay. So the data which basically I've got, I have added few more variables as we discussed, right? That family size, so how many number of people you have in your family. Monthly income, that what is your monthly income, okay, and how many number of children you have. And which is your basically location of the house you have rented out. So that is like whether you are in urban, suburban, or rural area, right? And whether you have cars, education level, okay, that how educated you are. Then again, our favorite field, which is dining out. And then so this is like monthly expenses are target field. So basically this is what we want to calculate. So I kept this variable for analysis purpose, but I think in the later on we will just predict this value. Yeah. So we'll move forward. So I think we'll just import libraries. So scikit-learn is what basically I'm using here. Some people call it a sklearn as well. So we will just import, and then NumPy, Pandas, very favorite libraries of all Python developers. So I mean, these are the them. Then for visualization, we have Seaborn. Uh, yeah, and then the last one is basically for ignoring the warnings, because your libraries keep changing, right? And then they are being modified every time. And then the old ones, which the functions which are already deprecated, they will then throw warning. So just for clean look, I have put this ignore warning thing. So here I'm just using Python to read the CSV. So I just got the data, monthly expenses data CSV, right? I loaded the data, then I created a copy of the data because I don't want to do modification on the actual data. So I will run with this the copy of the data. So this is your data overview. This is what we have. So I think we are just, I'm printing head, so basically which is printing your five top rows from the data. Then uh, so we have around 500 records and we have eight columns. Then we have, so this is the information about the data. I think uh, so as this data is like very probably the simplest data of what we can use for calculating your monthly expenses, because it's created for just for demo purpose, right? So that's the reason I think you may not find complexity in this data, but usually then the real data would be a lot more complex than what you see here, right? And you have to do a lot of modification on that data, you have to clean up that data, right? You have to remove duplicates, you have to correct some values, maybe because see data is coming from multiple sources, right? It is coming from different pipelines, and then it can be corrupted. What if, like, monthly expenses given in negative, right? So expenses will never be negative. So what you need to do, then you have to clean that data. So that data preparation part you will be able to do when you really get the actual data from the real world. So this is like a statistical significance of this data. I think probably we'll move forward when we compare, then we'll, I think, cover these things. uh, there is no null, I mean there is no duplicates and all. So I think because this is demo, right? So that's the reason we have very easy life here. So let's go to that exploratory data analysis, which is very important part of it. I really, I would like to highlight and mention one thing here, that in the moment you look at your data, right? I mean this phase of your model building is very critical, very important, because you can visualize the data, you can predict a lot of things even before going to a model, right? So sometimes what happens is that, if you do this part pretty well, you need not to actually put a lot of efforts from your data from model expectation. You would be expecting things by then already, that okay, I think my data looks like this. I can see very high level that this could be the case, this could be the deciding factor. Okay, so out of all my factors, my monthly expenses could be majorly dependent on this, right? By the time you really calculate the model and get the values, you will already have it. So I go here, I think probably just created some utility functions. Okay, so just to drop so basically draw some diagrams here. I used as I said SNS. So uh, I'll just hide that. Okay, and then, like, so there are two part of this EDA. So your univariate analysis, which is that we'll just see the distribution of the variable in the data. Okay, so that how well the data is distributed, whether there are outliers, whether data is right skewed or your left skewed, right? So we'll look at the data, and then probably we'll make some observations from the data. So now we'll see. So monthly income, so if you really look at it, monthly income is this. So there are, I think, probably some outliers, less than 10, I think, very less outliers. And this can also be a problem in data. Okay, so you also you need to be a bit careful here, that this data, when you see, you have to sometimes verify, and sometimes you have to use your common sense, or your business acumen, to understand whether this data is essentially a uh, it's an outlier, or it's a problem, or it's a problem in the data. So whether you have to clean this, I mean you have to remove this, or you have to consider this, right? So those decisions also you need to do based the way you look at the data. So this is like monthly income, right? Monthly income, I mean, monthly income, because there are a lot of rich people, so monthly income can be high. So probably this is the outlier, which is not a problem in the data, right? So as I said, the because of this outlier, essentially, this has become rightly skewed. Okay, so if your family earns significantly more, and there are few outliers, right? So then you have for family size. So family size, I think I think there's a one outlier. Some, I think, probably few families have a lot of kids probably, or maybe they are still living as a joint family, right? So not the nuclear family. So but mostly data looks were quite smooth. I mean, mostly we have 3 to 6 people, I probably as a family size, right? Mainly. So if you see from, you can look at the data from here. Then number of children, yeah, so number of children are very uniformly distributed, right? So this is how the modern families are. So mostly have 0 to 2 children, right? And then so this is our favorite variable, dining out. Yeah, so this also has some outliers. Probably some people are, they still go out a lot, probably they don't eat at home, or they always remain in parties. So skewed, right? Most family do dine out 0 to 5 times, but a few are clearly living that foodie life. Yeah. So then we, as in location type, so location type is quite uniformly distributed. So we have good representation from rural, urban, and suburban. So good thing here. Then we have whether a person has car or he didn't have car. So I think that also very uniformly distributed data what we have. Then we have your education level. So education level is like, you have. Let me see. We have already got the. Okay, so there are, I think, some PhD candidates here. If you go here, so yeah, so which are like, you see outliers here. Yeah. So now we come to bivariate analysis. We see the correlation between all our variables, so which looks quite clean. I think there is no correlation. If you really look at it, uh, I mean, there is no correlation at all, right? So correlation is like, you will be having from -1 to 1, hmm? And -1 and 1 probably they are strongly correlated in negative direction or in positive direction, right? So here, if you see, we don't see any correlation. So uh, we are we are good to go. I mean, we need not to uh, have a serious problem of multicollinearity. So we need not to worry about it, right? Again, it's a demo data, so so life is good. I mean, looks good. I mean, in real life, the life is not that great. Okay, you have to basically address these issues. Yeah, when if you look at in the data. Then we have so correlation with the target. So this matrix gives us some understanding upfront that my monthly expenses are basically dependent on these variables that we know, but how strongly they are dependent on it, or basically how strongly they are correlated with the other fields, right? So if you really look at it, monthly expenses, they here, if you see, let me come here. So your monthly expenses with monthly income 0.68, which is very strong correlation, right? Very strong correlation means people who are earning more, like their monthly income is more, they tend to expand more. I mean, and which is basically as expected. So as we start earning more, our expenses basically also grow up. Yeah. Similarly, if you really look at a number of children, so if you have number of children more, your expenses tend to be on higher side. Similarly, location type also, like, when you have you are living in a posh like, place, then probably you will end up spending more. So same, I think I have just put in mm, the correlation, and their uh, the the meaning, that why that is correlation, and why, what could be the. So here in this part, if really, I mean, what you need to do is that when you look at this data, right, you need to put your thoughts here. So, like, suppose you put your thoughts here, so that this will be a bit helpful when you go later, develop a model, and then when you are doing a evaluation. So when you're doing evaluation of your model, right, your thought process will help you come up with a better model. Of course, I mean, there are uh, statistical parameters, or some formulas, calculations, they will help you decide on the right model. But sometimes the decision is so close that you have to basically also understand from the data. So here you put your thoughts, right, the way they are put here. Right. So, like, if you're frequent dining out, then you'll have more expenses. Location, of course, yeah, we all know that, uh, if you renting in urban like areas, right, you have to pay more, right? So similarly, family sizes, car, education level. In this data, I think we don't see that high correlation with the cars, which usually people have it because if they are driving a lot. But in case like suppose you are in a country living in a country where public transport is really damn good, right? Then you may not be driving car so frequently, right? So for an example, if I give you example of Singapore, right? So public transport is that great that you don't actually require, you don't need a car. Okay, so even if you have a car, you may travel with the public transport, so your expense of car, like your maintenance and all, will not be that much. Yeah. So now we coming to monthly expense location type. So you can see that the expenses are rising based on the location. Yeah, this we expected, and we saw from here as well, from this matrix as well, right? Then education level, same. I mean, probably I mean, looks like from here that if you are more educated, your expenses probably bit beyond. But I think if you really look at it, there's not that great difference. It's very minor slight difference only. Then your scatter plot, I think these are very I'll tell you, I mean, this is very favorite diagram. I mean, this plot is very favorite of people, because this gives you a clear understanding. See, if you really look at it, monthly expenses going up, monthly income going up, very very easy, right? Yeah, so I think we'll just move forward. Now we do the data preparation. So I just think we will now what we'll do, we'll just moving to the building the model. So we'll remove our monthly expense mm, from the data which we are going to predict, because this is like why is like the prediction what we want to do. Hmm. Then splitting the data in 80-20 ratio. I mean, this the ratio you can change to 70-30 as well, right? Based on your model. I think later models, when you go right, when you advance machine learning and all, there you also need to have a validation data as well. So preferred, then you will have three sets. So you will have your training data, you will have your validation data, and then you will have test data, right? Correct. So yeah, so I think we'll just made it 80-20. Here we go. Okay, so now then, as we said, we'll first go for single linear regression, and I'm just keeping my favorite variable here. So I just created a linear regression model. Then I'm just printing their coefficient. These are nothing but same slope and the intercept. Okay, y-intercept and your m in our favorite y equals to mx plus c equation, right? So these are slope intercept. We got we just printed it here. So this is the our line, right? This is nothing but what we just saw. So we saw, right, b naught plus b1 x, right? Similarly, so basically this is your then your that's the problem here. So I think it's a monthly expenses actually, not sales. So then similarly, okay, so this is your best fit line. Okay, so you basically, now this is the regression you have done already. You have gone through that the training data. Okay, you plotted the training data monthly expenses based on dining out. This is nothing but basically the extended version of the equation I shown you in starting of when we just started calculating monthly expenses. So this is your basically best fit line, out of all these data, and which looks okay. I mean, as far if you look at this data and this data, but then how it looks okay, because see, what you need to verify is that the distance from your these points to this, to the points on this line. If this distance is lower, you have a better model, right? I mean, you some of the calculation will cover the same concept later on. Yeah. Then we also did this multilinear regression. So multilinear regression again. Now here we are considering all the fields. So if you really look at it here, what we did is uh, we did dining out, only dining out. Okay, so we just use single independent variable. But in this case, we are using all the variables. So basically, entire data set with all the variables. Right. Similarly, so monthly expenses, you can see. Now this is the interesting line you see here. See, so if you see, this is constant 181 family size. Okay, so interesting. So no, sorry, this is not constant. Huh? So this is basically coefficient for family size. This is monthly income, then your the number of children. So these are the coefficient actually. So from the regression, you identified the real, the predicted values of these coefficients. Location type, whether you have car or not, education level mix, dining out, and then this is the basically this value is your the constant. So negative value actually. Okay, so these are utility functions for further analysis. Right now we'll just go through the okay. So before I go to the model performance evaluation, so see if you really look at it, what we have done is till now we have calculated your single linear regression and then your multiple linear regression. Okay, so two models we have developed. I mean, with one dining out and with all the variables. Now we go for the model performance evaluation. But before we go there, let me I think explain you a few terms which are required, to understand, this thing. So this is again root mean squared error. So this is the formula. I think I just didn't put the formula here, but essentially the essence of this formula is it punishes big mistakes more because it is square. So what it does is essentially like suppose your actual expense is 4,000 and prediction came 4,500. So your error is essentially not 500. It is basically square of 500, and then you take the mean and then you take the root of that data. If you go for mean absolute error, this is simple the difference. So you 500. So this is basically this didn't punish that much for the big mistakes, right? So usually we don't want to we want to basically punish the model for more, I mean, bigger mistakes. That's the reason if you then you have to look at this basically formula and then the output of this, that what score we got here. Then you absolute percentage error, nothing, same thing in the percentage terms. So your 4,500 minus 500 divided by 400, sorry, 4,000. Then R square. So R square is again another measure of calculating. So it is like 0 means your model is uh, 1 means your model predictions are perfect. 0 means your model is not good. Adjusted R squared is, I think this is another good concept, uh, because now if you really look at it, how many variables we have here? 8, 9. Okay, if you want to predict like good model, we might be thinking you might be thinking that we if you can add more variables here, then I can basically get a better model, but that's not the case. Okay, so you have to optimize it, and this adjusted R squared basically penalize you for adding useless features. So you can keep adding feature, but they have really no impact on your final monthly expenses, right? So yeah, so this term that this is also very good if you really look at it. So this error, this is your error, this is your MAE, then map, then your R squared, and then R squared. If you really look at it, we were expecting something close to 1, right, for our model to be good, but we got something 0.21 only. So this is very clear, this is not a good model, right? Same performance also. So this is like on your training data, this is on your test data. I think not much difference. I don't see much difference here. Okay, actually it basically worsened on test data. It basically went down very badly. So now we go to multiple linear regression. There we see, wow, so this is 0.93, which is almost close to 1. This is on training data, right? If you really look at it, this is on your test data. So quite good numbers. I mean, the performance didn't deteriorate much, right? So essentially I don't see overfitting as well. So the model didn't. So overfitting is like model sometimes what it does is it basically remembers data rather than learning from it. It basically mugs the data. So that is overfitting. We do over. So now this comparison we do here. Okay. So this is your with dining out one. This is all independent one on the test. So if you really look at it, this is 0.93, almost similar performance. So yeah, so I think what we see that as expected, multilinear regression wins over simple linear regression by miles. As the earlier has low RMSE, so all these numbers are low. Then R squared and adjusted are quite good. Hmm. then one or two variables may not predict. So I think this is very clear from dining out. We use dining out as a one variable to predict your monthly expenses, which is not good. So one or two variables may not predict your monthly expenses correctly, as your expenses depend on multiple factors, which we know already. Dining out is a bigger factor, but not sufficient on its own. Right? Our square values are closer 0.93, so very good. The income drives the monthly expenses the most. This is again, so this observation directly came from your EDA. So what we said, right? So we also need to put these observation or thought process, that how the data is essentially. And then in this case you can also put, like, like further, if you like, if this model is not good enough, then what improvement you need to take, so that your the other teams, or your team, or whenever you take up another project, you can look at it, that what things we can improve. So I think we done with this linear regression today, and then now we'll move to our favorite topic, which is your nothing but hands-on fraud detection. So I think let me see. Let me add the file here. Okay. So fraud detection data set. Okay. So this also, I think I've already run the this thing. So just to save time, in interest of time, I think we'll just check 822. Okay. So I think we have. We can go through this model, so that just want to give some more time for the QA, but I think we'll just cover this. Yeah. So fraud detection. Yeah. So this is very important topic. I think I just want to explain things. I think though we have already covered things there. So fraud detection, I mean, as I said before, that in early days, or even like just few years back, the fraud detection was just very static form. Okay, so if you change your mobile number, if you change something, your device, right? That's it. So you just put four fields. Your what will happen? You when I made a transfer, or when someone made a credit card transfer, right? So you will have some this location data, your behavior, right? So I think I'll just tell you one interesting incident. So I traveled from Singapore to India, and when I landed in India, I for something I had to take some money from an Indian bank. So I withdraw some amount, I think probably 50K INR, and then when I withdraw the amount, I just got a call that, sir, you made a transfer of 50K. Is it really you? So this I'm 100% sure that this was not AI driven. This was not AI ML driven. This was driven with simple static rule, because this person, because I went to India, I mean probably after a year, and they already have seen it that I'm an active user. Okay, I don't withdraw money at all, right? Because I'm not active at all. So suddenly I made a transfer. So then okay, they said, okay, fine, this guy is not active. He's made a transfer. Let's check with him, right? So the old system were good. I mean, this system is also, I mean, probably at least they are saving some frauds. Uh, so this one, they called me, then they asked me, yes, I made the transfer, and then probably the release the payment, right? So similarly, what happens is in the real world in bank side, that when you made a transfer, whenever we feel that this could be fraud, right, we stop it. So we basically hold it. Stop means hold it. So it just basically that it is not passed, right? We will hold it, and then we do some additional analysis on the that who made the transfer, right? What kind of, is it a new user, or is this guy active already or not? Okay, and is there any possibility of fraud from different data sets, right? Then we release the transfer. So this process was like a static till now. Now because see, the another problem with payments finances is another problem is this, that this field is very rewarding. I mean, so I know that that if you do a fraud, I mean, like anyone working as a fraudster, right? If they can catch few people, I mean, their job is done, right? They need not to do anything. They can simply get money, and millions of dollars, right? Are being lost in fraud events these days. So they are becoming smarter. So fraudsters are becoming smarter than us. They are basically, probably I would say, I mean, it's not good to say, I mean, we are being a technical person, but that's the truth, that they are smarter than us. They are, they are probably a few steps ahead us. So, but at least what we need to do is our system should be smart enough. Our system should be smart enough to 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 basically detect those frauds. Oh, I think I saw a new pattern. So there's a new pattern emerging, okay, from my transactions, which looks like fraud. And the time from recognizing, so first of all, basically recognizing those patterns, identifying those patterns, then after identifying those patterns, that implementing them, basically stopping those frauds. So we have to basically look at the identification, quick implementation, and stop the fraud. So very this field, I think, probably, though we have already moved from static models to machine learning, then probably smart models. So now we are doing unsupervised learning, then supervised learning, but we still have to be, we still need to refine those models, so that we can detect new patterns quickly, implement quickly, and stop the frauds. So very important topic, I think, I would say. So this okay uh, this session is more focused on identifying those patterns, okay, identifying those new emerging patterns, right? So that I can do feature extraction, and then once I identify the features of the new fraud, I can fill in those features to my supervised learning model, which will basically actually do the fraud detection. Oh, yeah, it is a fraud, it is not a fraud. So it's a two-step process. One is your offline process, one is your online process, right? So real time is online, which, so the offline process will run, probably you can have a nightly batch job, something to basically put the features to your ML model, which will do the supervised learning and detect the fraud. So objective, I think, clear, that as a data scientist, we are basically okay. So I think I just want to put that I will be using k-means clustering to do this. So we'll be just identify clusters in the payment data. Okay, and the data again, this is not the real data. This data is basically created only for education purpose, but it has but I have tried to put things in perspective, so that you can get a good feeling of it, that how features could be in real time. If I really tell you, there are around close to 40-50 features extraction what we do from payment transactions, right? So this is data dictionary. So I think amount, I mean the amount being transferred, time of day, what time the person is transferring, okay, it could be night, it could be day, it could be afternoon. Then user activity level. So user activity level is uh, sorry, yeah. Okay, so user activity level, whether this guy is highly active. I just gave you an example, right? Because I was not active at all, so my activity level was 0. Okay, so then your day of week, the which day I'm actually making transfer, whether it is weekends or it is Monday, like weekdays, like whether Monday, Wednesday. So payment method, what payment kind of this, whether it's a card payment or a bank transfer. Another important point is new user, whether this guy is a new user. What happens usually, that people, they the fraudster, they they will basically open an account recently, maybe 1 or 2 days back, and then they will just basically quickly get activate, do the fraud, take money, get withdraw the money, close the account, right? So new user, this data also very important. Then is fraud, whether this is possible fraud. So I think this is just for learning purpose I have used. Usually your feature extraction will not have this is fraud field. Okay, it just basically I just put in whether just for EDA to understand that whether this variable is responsible for fraud or not, right? So I've written that as well here. Then so you will import the same libraries, no change there, right? Now we do data overview. Yeah, so head, tail, we have around 600 records, 7 columns. Then info, I think data is all good. We have one object, so basically this is string payment method, because you have card or bank transfer. Remaining all are numerical data. Could be your new user is basically more on a categorical variable. I don't have any null. Good. Because this is also a demo data only, so I didn't keep any null, right? No duplicate. Okay, but if there is, we have to clean the data and correct the data. So this is, I think, analysis on the data, which is quite important. So I think just go through, we'll just go through quickly so that we understand that what kind of data right now we have. Okay, so numerical, so we have numerical data, we have amount, uh, range. Okay, I think this is okay. So amount we have, so amount range is like from 0.66 and to 308, which is a quite high amount. Okay. Then your mean of the data, median. So it looks like quite right, skewed, right? Because your mean is more than the median. So may have outliers on the higher side, looks like. Then time of day, so 12.6 activity peaks around noon, right? So see, this is very important feature. So if you really look at it, the amount variation, we need to see, how the amount is varied, right? What is the distribution of the amount. Okay. And then what time that amount is being transferred. Okay, very important feature. So we'll, I think probably when we go look at the data, we will learn more on it. Again, user activity level, so till 12.47 is very high activity, 12.47, right? So max is this, suggesting a few hyperactive users, which looks like a problem. So unless you are basically paying, you are using your online transactions for, you are like, you are a merchant or something, and you are using your account for paying this, the other, the. If you are normal user, I mean, where all we spend on food, lunch, breakfast, right? And maybe rent paying, right? We shouldn't be that active. Day of week, which day you are transferring the amount, then your, this is categorical variable, new user 1, uh, existing user 0. Okay, so looks like we have huge number of new users. So this, I think, probably intentionally created, because new users, they tend to be, more fraudsters, right? So this is the reason why we have put in this data here. Let's go to the EDA, which is like very interesting part. Yeah. So this is the amount distribution. So you have right skewed. I think mainly the amount is, transferred is on mean, like, mean and median are almost 50 to 60, correct? But you have higher transaction as well, which is being transferred. Hmm? Same. Let's go to time of day. Time of day, if you really look at it, mostly the amount is transferred, I mean, during the daytime. So your morning 10 to 3, where I think it looks like lunchtime, right? In this thing. So people do a lot of transactions. But if you really look at it, there are some transactions which are in VRs. Okay. So could be, I mean, this could be of our interest, right? At the night, people are sleeping 3 o'clock, 2 o'clock. Okay, unless we have party goers. So, but if you really look at it, morning 4, 5, I think people are transferring money, which could be a problem. Okay, then we have user activity level. So user activity level also, you see, normal activities are here. Okay, but there are uh, high user activity level as well. See, so this is all entirely rightly skewed data. So we also, this entire area is basically interest, or interest for detection. Then come to day of week. Day of week is okay. I think people are transferring money in weekend as well. Middle is more data. That's okay. Then we have payments method. So we have, I think, probably a good number of, I think, good, quite balanced data, bank transfer and cards. Then new user. So as I said before as well, that new users, we have, this data is slightly skewed for more new users. So I think it's big number, right? 87% something. So we come to bivariate analysis. Yeah. So we don't see any correlation between variables, because yeah, this is demo data. So we don't see. But usually you will have correlation in few fields. So you need to just address that collinearity. I mean, yeah. Then your this is your uh, this is what we see. So fraud, as I said, that I kept this variable just to get a feeling that which variable could be indicating fraud more. So if you really look at it, user activity level, if it is high user activity level, there is a possible fraud. See the correlation, almost 0.69. right? So one is highest, right? So the 0.69 is quite big, strong correlation. So day of week, if you can see the numbers from here as well, time of day. So you see user activity level 0.69 and is possible fraud. Again, day of week also good indicator. Amount as well 0.43, right? So this number, if you see your user activity level, day of week, time of day, new users. Now I think we go for a scatter. As I said, that scatter plot is like a very important feature. These diagrams are really good. They tell you everything very clearly. So you look at the data, and that tells you a lot. So what do you have? User activity level very high, right? This number is very high. Amount very high. This side, and possible fraud is red one. So this entire amount is possible fraud. Higher, so user high user activity level, higher amount. But if you really look at it, this guy, this the blue portion, these are normal people. They are like me and you, who simply okay, they want to eat food. Okay, fine, they'll pay. So probably 2 or 3 transactions a day, right? And then amount also very less. So they'll pay only that only for food or normal amounts, right? Very this scatter plots are really very important. I'm telling you, there are very other complex diagrams, okay, to show the statistical analysis. But I think these diagrams, if you follow, they give you the exact correct picture. So then you have user activity level again. You see here, new user, I mean equally, whether the old user or new user, it looks like fraud possibility in activity level is high. Then you see your time of day. So this we discussed, right? V hours, the possibility fraud is more. Very much clear from the data. So essentially, if you really look at, you have just gone through your data. You just did EDA. If you do EDA properly, right, you already have an idea. You already have an understanding that where the problem lies. So not that easy, but because you have to do this, and you have to understand, because this data is very 500 records. When you have millions of records, and then from there getting these pictures, creating these clusters, right, will be difficult. Yeah. So I think we'll do data pre-processing quickly. I think there's nothing much here, so I'll just skip. Then data scaling. So we'll just scaling, just normalize the data. Okay, we will so that we can put perfect scale. So we are using standard scaler, okay, so that data can be drawn, visualized clearly. Okay, because clustering, we don't want basically one variable high value to impact the clustering, the visualization of the clustering. So we did that. Then this is like description we have already made. Mean 0, standard deviation 1. So just we have normalized the data. Then so dimensionality reduction is a very good feature, because see this data, what we have seen, we have multiple variables, right? So the data is changing based on multiple variables. So we'll have 7 8 variables you have. So how will you draw, how will you visualize the data, right? How would you know that which factor is impacting the outcome, right? So if you reduce the dimensionality to 2, I mean, so there are method already, they probably this class we cannot cover today, the science behind it. But just understand this way, that only for visualization, but visual, okay, but it shouldn't be the case that for the visualization you are removing the relationship, or basically you are impacting the relationship between the variables. So without impacting the relationships between the variables, okay, without impacting the effect of a variable, of basically of an independent variable on the dependent variable, you should be able to reduce the dimension. So that's what we is done here, and this is what we looks like. So in 2D, when we got, this is what my data is. So if you really look at it, I could easily, and all those 600 records, right? All those basically 600 transactions, which are in bank transfer, card. done by new user, old user, done with high amount, low amount. I'm able to basically, see these, you can say four cluster or you can say three cluster. I think we'll see further that how it is, but looks like from this view looks like four clusters, right? So could be, I mean, this, if you can say this cluster is same, or if you say this cluster is same, then probably three clusters, or you, if this is same, then again three clusters, or one, two, three, four, all four are different, then four clusters, right? So this is what we understand as of now. We draw, I think, probably just for better visualization. uh, so perplexity is concept. So based on that we can see which, I mean, if we varied the perplexity, see the data, that how it looks. But if you really look at it, this looks clear, right? This also very close. So 20 or 40 is what we understand. I will go ahead with 40. Okay. So I'll take 40. So this is basically popular dimensionality reduction technique, often used to visualize high dimensional data in lower dimensions, example 2D or 3D, before or after clustering. Okay. So so this is a TSNE perplexity roughly correspond to the number of nearest neighbors each point considers when learning the local structure of the data. Hmm. So that's okay. I think probably I'll just give you probably, because this is not detailed class, but these clusters, how these clusters are formed, I'll just basically spend a minute there. So these clusters are formed by calculating so what they do, they pick up randomly, I mean, these techniques, right? The K means technique. So they basically they pick up data, right? They pick up some centroid, and from that centroid they try to calculate, I mean, this is how they decide, okay, fine, this data is part of this cluster or not. They calculate the distance from that centroid to the web variables. So the distance from from centroid of x one cluster, and like centroid of another cluster. So distance from like centroid of one cluster to this point should be less, and more to the centroid of another cluster. So that's how they basically create clusters in it. So I mean, this can be easily seen. Like, so if you really look at it, just what I'm trying to explain is that, like, suppose centroid of this cluster is in between, right, in this here. So from that centroid, distance of this point, like suppose is 10, right? But if you, from the same centroid, if you I see the distance of this point is, could be more, right? So that's the reason this point is here, this point is here. So if here also I see, looks like four clusters, right? So now then we go for help. So I think probably there are two methods. So to basically calculate, I mean, how many number of your clusters you want to basically go ahead with. I mean, they say the optimal K value. So K value is like, if you really look at it, we are expecting high WCSS value. So more than, it is going down. So if really three looks like good, I mean, two is very low. So they go, I mean, you can go with either three or four. Okay. Then there is another technique. So based on that also, if you really look at it, three looks like okay, because if you really look at four, right, it, the the score is coming down very, drastically. So okay, so I think I can take either three or four. But I went ahead with three, and then with using three. Okay, usually what happens, right? This is just basically I'm using for a demo purpose. But usually what happens, you have to change these parameters, and then run the model. Then probably you take four, then you run the model, and then see the scores, that whether you are able to rightly predict or not. And then based on that you decide, okay, which model works fine for you, or which model works fine for the data what you have. So based on data, these values will be identified, and then when you have confusion, you try to run those two three permutation combinations and try to come up with the score. So yeah, so I think we use three as a value, and then see, this is how it is. So we created three clusters actually. So this is a separate cluster, this is another cluster, and this is another cluster, right? So and this is how it looks in 3D model. So the blue one is one cluster, quite big. Okay. Then red one is another, yellow one is another. There are some outliers, pending here from this cluster. So this is like distribution of the clusters. You see, I think probably the cluster one, which is like index 0, is having like most of the data. So 500, almost 500 records. Remaining two, cluster one and cluster two, are another 100. Then this is the now, okay, now our job is basically to understand the characteristics of these clusters, that what these clusters are basically created by your model based on what criteria, right? So basically, okay, the criteria what they use, they just identified that they are related. Okay. So points on these clusters are related. Hmm? Now these characteristics we need to see that what what characteristics these the models have. So if you really look at it, cluster one, the amount is amount transferred is normal. Okay, index 01. Cluster 2, which is index 1, is very high amount. Cluster 3, very low amount. So from this diagram, it looks like this could be a because high amount transfer, right? So this could be a fraud related data. But let's see. So time of day, again this cluster, again see the cluster 2 only. Then you see cluster user activity level as well. Now the last cluster has a high user activity level, right? This is also high compared to this one, the first cluster. So still your cluster one is a candidate, probably candidate for for fraudulent transactions. And this is your day of week. Yeah. So same data, I think probably these are the bar chart for the same data. So now let's go to yeah. So I think looks like, I mean, what we understood from this is that cluster one is having high amount transacted. Day time of days V hours, correct? Then this one also, if you really look at it, this is like user activity very high for second cluster. Hmm? And then second, your day of week also, cluster one and cluster two. Then new users are basically and everywhere, right? So now we'll just analyze the clusters. We'll see the, so this is how the your clusters are here. uh, you see cluster 0. So in cluster 0, like index 1, you have, so 98.6% transactions are not fraud. Only these ones are fraud. So 0.01, negligible. If you go to cluster 1, which we just saw, higher amounts. So this is just one, but this is looks like a fraud cluster. Similarly, cluster 2, this is also fraud cluster. Now you see average amount per cluster. So first is around 50. I think we saw from EDA as well. Then this one is almost 200 average amount in cluster 1. Cluster 2, also less amount. So now then here we need to see, the uh, so cluster 2, if you really look at it. So I just ran for cluster 2. I mean, basically this is cluster 3. The index is 2. So cluster 3, if you really look at it, this all fraud events. And what is happening? This guy is transferring. I mean, the fraudsters are transferring less amount. Okay, but the activity is very high. So probably they are doing more transactions with the less denomination, right? So the the amount transferred is less, but the frequency is very high. So number of transactions are very very high. So this is like basically this characteristic of, so basically this, so this cluster, basically number 2, this one is also fraud, but the characteristics are a bit different than the cluster 1. So this cluster 1 The thing is that in very the amount is very high transferred. Okay, and then here if you really look at it, the amount is less, but the frequency is very high. Here the amount is very high, but this amount is also transferred, during VRs. See, time of day, very high amount transferred VR. So this is the feature. So basically now this is the feature. So for fraud, we now identify very clearly that during VRs, high amount transaction or possibility of fraud. Second case is very high activity, normal timings, but amount is very low, the user activity is very high, also a possible fraud. So now from these cluster, the characteristics of the clusters, right, you can identify. Okay, so I think this analysis I just put in here just for understanding that cluster one index zero contains less like 0.01 fraudulent transactions, indicating a low risk segment. So we can basically ignore it. Then cluster two, high risk concentration, high fraud concentration. The key characteristics are very high transaction amounts. Transactions occur during late night or early morning hours. Number three, low transaction amounts, but normal transaction time and day of the week. Unusually high user activity level, suggesting potential automated or anomalous behavior. Clustering is performed offline. So basically, okay, now I think as I explained earlier, so now this entire process you do offline. Okay, it will be done offline. You already identified. Now these are the feature extraction. So you already extracted features from your data. Usually it is done on historical data because banks have past, I mean, at least by regulation itself, they have 7 years of data, right? So they pick up that data, they learn from it, identify the features. Okay, they also know, because what transactions were fraud, because customer have complained to them. So they extract these features. Then we, after extracting these features, what we do, we take those features, put into nightly batch job something, feed into the your machine learning supervised model. Okay, so this is unsupervised model. You feed into supervised model, which will basically make a decision whether it is a fraud or not. To just want to also understand, people, I mean, people who are uh, trying to replace their old models, so they need to run their old models parallelly with the machine learning model before you get confident on your new machine learning model that this is predicting fraud correctly. Then probably you can replace, or you can basically also have your old model as a fraud detector, uh, just to give you additional information until you really get confident, and then only you decommission your old model. So yeah, so I think that's all for today. Probably I think we have 7 minutes. Okay, now we have, I think, probably, yeah, I think, yeah, so we have 7 minutes left, I think, for QA session. So the floor is open for question answers. Is anyone speaking? I cannot hear.
Hello, Manoj. Can you hear me now?
Yeah, I can hear you. Yeah.
I have a question. I think it's a little bit behind the scope of the session, but I want to get from your experience in banking industry or in finance in general. I'm working on a cross selling task that I want to recommend the credit cards to specific segments of customer. I already built my data that I have the transactions, debit transactions, and demographics and other products that the customer have. So, what do you recommend that is a suitable way to build a machine learning model in this data? Not that I have already tried different classification models, but I can't find the set of features or the features that can separate two different segments that customers who have or customers who does not have the credit card.
Okay. So, okay, I think good question. So, Mustafa, I think probably what we can do, because probably that will require more time. You can touch base with me, separately. You can ping me on LinkedIn. Hmm. Let
Yes,
me
sure,
let me
sure.
ping my yeah. Let me ping my LinkedIn. Uh, just a minute. So you ping me there, and then probably we can touch base. We can have a one-on-one call. Hmm. And then probably we'll go through your notebook, or I mean wherever you have the data, or probably whatever information you have, and then based on that we can do some brainstorming together, right? And then we can help each other. Yeah,
Yes, for sure. Thank you.
yeah, welcome. So someone complained, Ahmad, I think you complained that you cannot see your screen, it was frozen. So was that okay afterwards, or it was frozen after 8:34?
It's working. It may be
Anyone can confirm, please?
internet connection issue.
Yeah, I think so. Salma, yeah, Salma Yunus also said the same thing. And then, yeah, Ahmad also, yeah. Yeah, Ahmad, I think you are responding. So, okay, there. Okay, great, great. Okay, thanks. Yeah, I got the answer. Yeah. Yeah, do we have any other questions? Yeah, I would love to answer. And then see, it's not the only place or only platform where you can ask me questions or we can discuss. I would love to answer your questions, on LinkedIn. You can also reach out to me on X. So I think formerly Twitter. So there also you can post your questions. Yeah. Uh, so I would be happy to answer, learn from each other, because that's how the industry is growing, and we all also have to grow a similar way. Okay, I think people are asking LinkedIn profile. Let me give again. Okay, yeah. Do we have any other question then? Yeah, or Acha, okay? Any question on the content which I presented? I mean, anything you want me to cover, or guys? And then one more thing, I think I would love to hear the feedback on this session. My so as I mentioned in the starting of the session, my goal, okay, from attending these sessions is of course to learn from each other, but uh, what I want to do is I want to simplify AIML for everyone, so that we can easily explain to people that this is the problem statement. So simplify it, and then get simple solution, okay, to address it, rather than getting into saying all jargons and all your complex things. Yeah. So I would love to hear the feedback, the parts which basically you think that could have been improved, or probably you say could have been put more information. I would love to do that.
Thank you, Manoj, for grounded and insightful walkthrough of AI in financial
Mm.
world. We will take a quick break. See you right after. Okay, thank you.
So just a minute, okay, let me give the yeah, okay,
Okay.
sorry guys, sorry guys. Okay, yeah, thanks. So I think probably please connect with me on LinkedIn or X, and then probably we can discuss more on there. Yeah, thank you so much
Thank
for
you.
this. Hassan Amir. Yeah, thank you so much. Yeah,
Thank
thank you everyone for listening patiently to me. Again, I look forward to the feedback. Thank you, guys.